Okay, so right here is the following redox reaction. Well, whenever you're doing this and you're trying to figure out something's a redox reaction, if you've already done the redox, the oxidation numbers, then this is really easy. Because if the oxidation numbers change, it's a redox reaction. And so here we see sodium was 0, sodium went to +1. It's a redox reaction. Sodium lost an electron. There you go. Now, you can actually do this without doing oxidation numbers as well. So all you have to do is look for a species that has gotten a greater number of oxygens or a lower number of oxygens. That's the easiest way to do it. So for example, hydrogen, H2 here, has an oxygen on it. So this is the oxidized species of hydrogen. This over here is the reduced species. It has lost an oxygen. That's actually the old definition. You can also look at the sodium. So the sodium here is neutral, right? Has a 0 charge. We know over here this sodium would have had to lose an electron to the oxygen, wouldn't it? So that means that's a redox reaction. So that's what the redox reactions mean. Yep. Something has to gain an electron, something has to lose an electron. And remember, that always happens as a pair. If one thing gains, something has to have lost, right? By the way, as a little bit of a commentary on the world in large, I feel like maybe people have unlearned that lesson. If somebody gains something, somebody has to have lost it. There is no free lunch. Okay. All right. Okay, so let's assign an oxidation number to each atom in the reactants. So here we have our reactants. What would our oxidation numbers be? So carbon is by itself. Let's get you. You gotta do one. Carbon here is by itself. So that means its oxidation number has to be? Okay, so again, we look at the carbon. It's just by itself. Nothing could have taken the electrons from it, right? And so whatever the charge up here is, that's it. Yeah, 0. Count.
So every time our element over stuff is always 0, right? That's right.
When you have an elemental form, a neutral element, it's always 0, yeah. God, somebody needs to put some damn tennis balls on the bottom of these fucking chairs. It's so loud.
What about if it's aluminum?
If it's Al solid, yeah, still 0. Or let's look at this oxygen here. O2 would be. Yeah, that's your elemental form, right? That's your neutral element. Or another way of looking at that is 2 oxygens can't take electrons from each other, can they? So, has to be 0. Okay, what would be the oxidation number for this carbon here then? Let's do this. So for CO2, what would be the oxidation numbers? Again, if you're going to do this, you'd always want to go after the more electronegative species, right? So I would always go after oxygen in this case, right? So the, yeah, that's pretty funny. Yeah, you're okay. The oxygen would typically want what charge? Negative, yep. Negative what? 2, exactly. So the oxygens are going to be -2 each, right? There's 2 of them, meaning it would be an overall, -4. There's no overall charge here, so that means this has to add up to 0, doesn't it? Okay. And so that means what charge has to be on that carbon? We had a -4, so it has to be...
Sorry, mine's different.
+4, right? Okay. Okay. What's up?
Mine says Al2, aluminum 2, oxygen 3.
For part G? Oh. Okay.
Or it's part H.
Okay.
But it's just
What was it again? AL
AL2O3.
AL2O3?
So would oxygen be -6?
Yeah, so the oxygens, each oxygen, your oxidation number for oxygen is always for an atom. The oxidation number for oxygen would be -2. You'd have then a total of -6 they have to account for, right? Is there a charge?
I'm confused on what the difference between the two problems is. One's the reactants and one's the products.
Yeah.
Oh.
Yeah. Each of these, you do the reactants, then you do products, then you do is this a redox reaction? They're really just sort of the same problem over and over, just almost. Okay. What should we do right there? See, there's no charge. So see up here, 0, there's none. Okay. Is that a negative charge? It would be negative or -1, -2. Okay, so you have your oxygen. Your oxygen is -2. Okay, so you have to put that in your mind. Okay, that's for the oxygen. The Al then, you have Al times 3. So you have 3 oxygens, right? Each of them is a -2. So you have to account for a -6 charge. Okay, so we have a +6 with all of the Als. How many Als are there? 2. So we have to divide that number by 2. You got it. Yeah. +3, right? So the Als will have an oxidation number of +3 on Al2O3, and then the oxygens would have a -2. Okay. Why are you confused?
Because, like, if it was 6, then why is it not 6?
Okay, how many? Okay, this is like paying 3 people $2. If you both are paying people $6, how much do you have to pay each? Do each of you have to pay $6? No. So you pay 3, you pay 3, right? And that's what the Als are doing. Each of them is paying out 3 electrons. Okay? Because they have to pay a total of 6. Does that make more sense?
I guess.
Seriously, step away from the chemistry, okay? It's not even a chemistry concept. This is a just basic math concept, okay? And really, this is just a basic real-world concept. Okay, so for electrons, we're going to say marbles, okay? Marbles are electrons. So you have 3 people. They demand 6 marbles. You have you and your friend. How do you pay the 6 marbles? You each give them 3, right? Yeah. And so you have lost 3 marbles, haven't you? Your friend has lost 3 marbles. So the Als, you and your friend, have lost 3 things, 3 marbles, right? To give a total of 6 lost. Okay? That's all you're doing is you're talking about individuals, individual atoms in this case, okay? And that's what your oxidation numbers are. Much like your bank accounts have individuals, right? You don't have a bank account with her, probably. That would be an interesting. Yes, we do, Dr. Clausen. So again, it's oxidation numbers are always for individual atoms, right? And your tallies are what you're doing to give an overall neutral molecule, an overall neutral compound. Okay? Okay. Does anybody have any more questions on this?
I just want to do again.
Okay. Oh. I3. Okay. I3 negative.